The properties of the rhombi. So of course, all the properties of parallelograms apply to rhombi because a rhombus is a type of parallelogram. Rhombi, by the way, is just the plural of rhombus. Right? So that means that both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. And you can see some of that shown in the diagram above. But unique to the rhombus is the fact that all sides are congruent. So not just the opposite sides, all sides. The diagonals are perpendicular. So not only are they bisectors, but they're also perpendicular. The diagonals bisect the angle, and it happens that the diagonals divide a rhombus into 4 congruent right triangles. Because all the sides are congruent, the diagonals are bisected. Right? The angles are opposite angles are bisected, and the diagonals are perpendicular. That's going to make those 4 right triangles. Now, not all of these could be proved on the coordinate plane. We really can't prove much about angles on the coordinate plane besides the fact that we have right angles. Right? So, but what we could prove, we can prove that the sides are congruent. So that's going to be the distance formula. And we can prove that the diagonals are perpendicular. Right? So the bisector part is going to be the midpoint formula. Perpendicular part is going to be slope. Right, so like the rectangle, we'll have to prove it's a parallelogram, but if we're proving all sides congruent, well, so are the opposite sides. So if we're using the number 2 there, we actually can prove it's a parallelogram, and with the same work, prove it's a rhombus. With method 3 there, if we prove it's a perpendicular bisector, the bisector part proves it's a parallelogram. The perpendicular part proves it's a rhombus. So these work out pretty nicely. We're going to do the number 3 first, right, in our proof. We actually have 3 ways to prove that a quadrilateral is a rhombus. Again, we'll prove it's a parallelogram first. Method 1, prove the diagonals are perpendicular. And method 2 and method 3 are so similar. A pair of adjacent sides are equal. All 4 sides are equal. Well, since I need the opposite sides being congruent for the parallelogram part, we already have all the lengths of the sides. We may as well just say all 4 sides are equal. So we're actually only going to do 2 proofs here. We're just going to call method 2 and method 3 really one kind because we can essentially accomplish it the same way. And then method 1 is its own way. If we're working with the diagonals being perpendicular, we should use the diagonals being bisected for the method of proving it's a parallelogram. All right, so let's get started on that with this proof. All right, so we're going to prove that the quadrilateral with these vertices is a rhombus by showing that the diagonals are perpendicular bisectors of each other. The bisectors proves it's a parallelogram. The perpendicular proves it's a kite. By the way, it would not be enough to prove the diagonals were perpendicular because that's also true of the kite. The difference is with the rhombus, they are bisectors of each other. With a kite, they're not both bisected. So that's why we got to prove it's parallelogram. So step 1, let's graph the quadrilateral. So -2, 3, and label that A. 2, 6, label that B. 7, 6, oops. Label that C, and 3, 3. And label that D. And so we'll connect. So let's go A to B to C to D to A. I almost went the other way. Not that it would have made a difference, but just want to be consistent for you. All right, so that is step 1. Step 2, what do we want to show? We're going to show the diagonals bisect each other. That's the parallelogram part. I'll put parallelogram next to that. And diagonals are perpendicular. And that'll show it's a rhombus. All right, so what formulas do we need? To show that the diagonals bisect each other, that's the midpoint formula. We have to show they have the same midpoint. So midpoint, we add the x-coordinates, divide by 2, that gives us the x-coordinate of the midpoint, and add the y-coordinates, divide by 2, that gives us the y-coordinate of the midpoint. And then to show the diagonals are perpendicular, that would be slope. So the difference in the y-coordinates divided by the difference in the x-coordinates, and that's our two formulas. All right, so now are the work. Oh, and almost forgot. We forgot to graph something. So if we're working with diagonals, don't forget to graph the diagonals. So let's just take a moment and graph the diagonals. That way we choose the right pair of points. Because if they're not points, if we don't find the midpoint of the diagonal, well then our work is useless. All right, so the diagonal goes from one point to a non-adjacent point. Since everything is adjacent except for the opposite point, you just go from opposite to opposite in a quadrilateral. All right, so now the work. All right, so we need to find, so first we'll find the midpoints of the two diagonals, and then we'll find the slopes of the two diagonals. All right, so the midpoint of AC, we add the x-coordinates, so -2 plus 7 divided by 2, and then we add the y. So 3 plus 6 divided by 2. -2 plus 7, that's going to be 5 halves. And 3 plus 6 is going to be 9 halves. There we go. Let's do the same thing and find the midpoint of BD. All right, so that's 2 plus 3 divided by 2, and the y-coordinate 6 plus 3 divided by 2. All right, so that's 5 halves and 9 halves. They have the same, the diagonals have the same midpoint, so that means they're cutting each other in half. All right, so we got the midpoint. Now let's find the slope. I think I can put the slope over here. All right, so the slope of AC, all right, so that's going to be the difference in the y-coordinates divided by the difference in the x-coordinates. So that would be 3, and I'm just going to go in order, 3 minus 6 divided by -2 minus 7. So 3 minus 6 is -3, and -2 minus 7 is -9, and that's going to reduce to 1/3. The two negatives will cancel, and that just reduces to 1/3. Let me just make that a little nicer. All right, so now let's do the same thing. Find the slope of BD. All right, so the difference in the y-coordinates, so 6 minus 3 divided by 2 minus 3. That would give us 3 divided by -1. That's -3. All right, so we've done all the work. Now all we got to do is write the proof. I'm going to do this one as a paragraph proof. I got lots of space. I was very careful with making sure I left lots of space. All right, so I'm going to start off talking about the fact that this is I always do parallelogram first, then rhombus. All right, because if I don't say it's a parallelogram, I can't say it's a rhombus. So since the midpoints of AC and BD are both 5/2, 9/2. Both diagonals bisect each other, making ABCD parallelogram. I got all that in one sentence. It's not a goal. It just works out that way sometimes. All right, so now we want to talk about, we said it's a parallelogram, now we want to show it's a rhombus. And let's make sure we didn't say midpoint formula, but we listed them, so it kind of implies midpoint formula, but let's include the slope formula here. Using the slope formula, the slope of AC equals 1/3, and the slope of BD equals equals -3. Since the slopes of the diagonals are negative reciprocals AC is perpendicular to BD, making ABCD a rhombus. There we go. All right, we got all the information in there in our proof. All right, we talked about why it's a parallelogram, because the diagonals have the exact same. We said what the midpoint is. 5/2 and 9/2 is the midpoint. All right, so since that midpoint is the same, both diagonals bisect each other. That makes ABCD a parallelogram. Then we use the slope formula, and we found the slope of AC to be 1/3 and the slope of BD is to be -3. Since those slopes of those diagonals are negative reciprocals, I would put in the word diagonals because it's the diagonals we were working with. And it's the diagonals that have to be perpendicular. So since the slopes of the diagonals are negative reciprocal, AC is perpendicular to BD, making ABCD a rhombus. So there we go. There's our first proof. And in the next video will be our second proof. Thanks for watching. Bye for now.